Thanks, Kate. Uh, Good afternoon, everyone, and thank you for joining us here at XConf today. Uh, we're going to be talking to you about automated governance and how we believe that can take your organization's agility to the next level. Agenda for what we'll be talking about today. Uh, we're going to be starting with a conversation around business agility and how that relates to the notion of flow. We can then look at governance more generally, how it's practiced within organizations today, and some of the problems associated with that. We can then touch upon how we can go about automating governance, as well as demo of some scenarios, automating governance using a service called binary authorization. And lastly, we'll touch upon some of the benefits and challenges facing automated governance and what you can what you can gain from that. Over the past couple of decades, we've seen a lot of different movements, philosophies that have championed practices that have helped organizations increase their agility. And what we mean by that is organizations can respond to the needs of their customers a lot faster. If you if you're a metrics person, then these practices have really helped us improve our throughput metrics. Some of the our lead time for changes, as well as our deployment frequency, for example. And the way these practices have helped us do that is by improving flow, the flow of value from an engineer working on code and getting that working software into the hands of our customers. Now, there are other ways to provide value to your customers, but for the purposes of this talk, we're really talking about delivering working software into the hands of our customers. Now, one might say that the easiest way to do this is really to give your engineers access to production and let them just start deploying code into production. Ultimate flow, right? I think most of the people in this room would agree with Boromir when he says that one does not simply deploy into production, right? And the people who would agree with him most vehemently is the governance, risk, and compliance functions within your organizations, or the GRC functions. These are folks who are responsible and have the accountability to make sure that risk is managed within your organizations. You need governance to be able to deliver value to your customers faster and more reliably. Because mistakes happen. Sometimes those mistakes are genuine and inadvertent, but sometimes those mistakes are intentional as well. And these happen because humans are engineers. Engineers are humans, right? These mistakes can sometimes be very damaging to either the organization, to your reputation, and worse, to your customers. Any systems that host financial data or personally identifiable data, medical data, changes to these systems really need to be done in a controlled manner. So what is governance really? Governance is that management of value creation and risk management within your organization. A lot of different organizations follow frameworks such as the 3 lines of defense framework, where you've got first, second, third line of risk, and sometimes the fourth line, depending on the industry that you're operating in. For example, could represent the regulator that you as an organization are answerable or accountable to. However, in most organizations, governance really feels like this, where it's heavily skewed towards risk management and not so much towards value creation. What this does for an organization is it inherently makes you more conservative and makes you slower to respond to market changes. That conservative attitude really creates that opportunity for your organization to be disrupted. And we see that most evidently in financial services today. You've got neobanks and fintech companies really challenging those companies, the major banks, for example, in their operating model, because they can get value to end customers a lot faster. But how did we really get to this point? So like we touched upon earlier, engineers are human, and sometimes we have bugs in our code, and we have outages or incidents that happen as a result of those bugs. Our typical response in most organizations is to increase change controls, right? Make it harder to get code into production, right? Because that's naturally, you have more checks in place, therefore that'll make things better, right? What that does though is it forces development teams or teams that are working on features to increase the batch size. Like, it's harder to get stuff into production, so let's take larger chunks of code and put it into production. That results in an increase in risk because you've got a larger set of changes, and therefore there's a greater probability that something might go wrong when you put that set of changes into production. And then you enter that vicious cycle again. And this goes on till your organization becomes very conservative and very risk averse. Let's assume that we didn't have this problem, that all of our code was perfect and there were no bugs. Let's look at another dimension of governance and the fact that how does manual governance practices scale as our ability to deploy working software improves. So back in the day, you may be able to do one release per quarter, right? And because of adopting all of those great practices, such as that DevOps champions or DevSecOps champion, you've been able to triple your ability to deploy, and you're being able to deploy 3 times as much. But really, the effort that goes into getting that working software into the hands of your customers involves a governance effort as well. And we're spending 3 times as much effort in going through those governance motions. So we've improved our ability to get software into the hands of our customers, but really you're spending 3 times as much effort in going through the governance practices as well to ensure that you're doing so in a controlled and reliable manner. This inherently does not scale. If you want to go from 3 times a quarter to 10 times a quarter or 10 times a day, your governance practices are not going to scale in order to support that. So what do we really want to achieve here? I think what we want to do is improve the flow of value to our customers by reducing handoffs so that our business agility increases. But we don't want to introduce risks which make operating our business harder, right? Your organization does not want to take on just any and every risk which makes operating a sustainable business, your accountability to regulators, your accountability to your customers becomes harder to meet. And we believe the answer to this firmly lies in automating our governance processes. So how do we go about thinking about automation of governance? The first thing we've got to do is start modeling our governance process within our organizations. Typically, governance, you have control owners within your organizations, individuals or teams that are accountable for a certain control point. For example, there could be a control point around test coverage and that's a quality control point, that your code that you're deploying into production must meet a certain test coverage. You usually meet that test coverage by providing some sort of evidence to those control owners. And this could be in the form of a form, some sort of test log, some sort of report that you as a team need to fill out. The control owner determines whether your evidence meets the criteria that they've laid out for meeting that control point and provide some sort of an attestation, some sort of evidence that, yes, you've met the control point. And you probably have a lot of these control owners within your organizations, some which look after single control points, some which look after multiple. And you've got to go to each of these control owners and get a sign-off before you go to a change advisory board or some sort of change management functionality and get an approval to go ahead with your release. And that, finally, you can get your working software into the hands of your customers. And this process is one which you can inherently improve. So before I hand over to Bal to talk about how we might do this, some context setting. Over the course of the next few slides, you're going to be operating largely within a Google Cloud platform as well as a Kubernetes environment. Now, this doesn't mean that some of the principles that we'll speak about are not applicable to a different environment that you're operating in. It just means that the tooling and the maturity of the tooling is better in the environment, in a Kubernetes environment, in a cloud native environment. All right?
Thanks for that, Satyam. I got this. That's all good. So binary authorization is a managed service by Google, which essentially allows you to secure your software supply chain. And it does that by collecting structured metadata during your build process. And whilst doing that, it also allows you to configure and enforce policies around your deployments. So let's go into some of the concepts behind binary authorization so that we get a better understanding of what this ecosystem looks like. So here we have our attesters who represent our control owners. We identify these attesters using a public and private key pair. Our control owner will codify a control point, which is tasked with validating that a requirement laid out by them has been met. The output of this codified control point will be an attestation. So this attestation is essentially metadata about our deployment and will be signed using the private key of the attester. And we use this as evidence that we've met a control. Binary authorization policies govern our deployments. They specify the need for specific attestations from specific attesters. And then we have our enforcer who validates that these policies have been satisfied. And it does this by checking for attestations, and it validates these attestations cryptographically using the public key of our attester. Once a deployment has gone through, it indicates that we've satisfied the controls laid out by our control owner and that we can go ahead with our deployment. So let's see this process in action using a few scenarios. In scenario 1, our control owner has essentially mandated that all deployments must have a code coverage of above 90%. Let's have a look at what this looks like in a real pipeline. So in our scenario, we have two key personas. We have Satyam as our control owner, so we'll be doing a bit of role play here, and we have me as the developer. So as a developer, I push a commit to trigger our pipeline. And one thing to note is that every step of this pipeline is run in an individual container for isolation. We then move on and test our application code, and then we package this up into a Docker image. We'll push this image to a Docker registry, in this case it's Google Container Registry, and then we'll move on to the coverage attester step. So this is a container created by our control owner, which integrates seamlessly into our pipeline. The purpose of this step is to validate that we've met the controls laid out by them. And if this is successful, we'll publish an attestation to a metadata store. The attestation is uniquely identified by the digest of the image. And then we'll go on ahead with our deployment. So we'll quickly go through a demo just to see what it looks like and see what a happy path looks like in this instance. So originally this was meant to be a live demo, but we had a GCP outage during one of our practice runs. Who knew GCP could have outages? So we'll push a commit to trigger the pipeline. And just to call out, we are using Google Cloud Build. So we're staying cloud native. And we're just checking that our build's up and running. We'll switch over to our Kubernetes cluster just to ensure that nothing's up and running at the moment. And then we'll switch back to Cloud Build. Here we can see our pipeline that we've configured and all the different steps. So you can see that we've got the test, build, and push steps for our image. And we have an intermediary step which just lets us generate our Kubernetes manifest for deployment. We then have the attestation step, which I mentioned earlier, which validates that we've met the control laid out by our control owner. And we've got a lot of useful logs here. So as you can see, you might have to squint, but the test score that we achieved for our deployment was 94. And in this instance, our control owner has said that we need 90%. So that means we've met this control, and we'll create an attestation as an output. We'll then move on with our deployment, which was successful. And we can validate that by looking at our cluster and ensuring that a workload's up and running. Cool, so workload's up and running means that we've completed this happy path and everything sort of works, or does work. So, looks easy enough. Let's have a look at what happened behind the scenes in order to accommodate this process. So here we have a Kubernetes cluster, sorry, with binary authorization enabled. What this means is that we have a validating admission controller set up on our cluster, which will intercept all deployments. We'll refer to this admission controller as the binary authorization enforcer. And this enforcer is tasked with checking against policies that have been configured by our control owner, which specify the need for specific attestations. In this case, it wants an attestation for us passing the test coverage control. It'll look for this attestation in the metadata store, uniquely identifying it using the images digest. And if it finds one, we'll move ahead with our deployment. So I'll now hand over to our control owner who's been eagerly waiting for the spotlight again. And he'll take us through our second scenario to see what it looks like when we want to change this control and bump up that test coverage threshold.
So one of the things about controls within organizations is that they're hardly ever static. As the organization changes, the controls also should be evolving. And this scenario is to bump up the test coverage, because 90% test coverage is so 2000s, right? We sort of move far beyond that, so let's bump that up to 95% and see what happens. So let's go through another demo. You'll notice that the coverage at tester container actually has a completely separate lifecycle and a different pipeline. So that pipeline is under the control owner's control, and we're going to go in then bump up the coverage to 95% and create a new container, which then integrates into our app developers, our engineering team's pipeline to use new updated control. Right, so we've bumped it up to 95%, and we're going to run that trigger. And that's going to create a new image and publish it to a image registry within your organization or on your cloud platform, which is then available for engineering teams to use. Right, so it's going through a few commands. It's going to put together our private key and put together the script which determines whether the control has been met. We're then going to trigger the app pipeline. Right, the app pipeline will pull in this latest image of the control and check against that when determining whether to generate an attestation or not. Now, you might be thinking, so as a control owner, you can just break my engineering team's pipeline on any whim and fancy. Well, that goes to the life cycle and how you manage that life cycle. You have to bring in best software engineering practices, such as the same way you would version APIs, for example. You have to be able to version these containers that you're shipping out there, or even better, create an API for it, right, and put it behind an API. So you'll see the same steps that are being generated, same steps that are being run through, and our attestation steps should start any point. All right, so that's kicked off, and it's going to pull in the latest attestation, and you see that step fails. And if you scroll down, you see that now it's checking for a coverage threshold of 95%, but it really has a threshold of 94. So it doesn't even generate that attestation. So let's go and see what's happening behind the scenes. So same thing all the way up till deploying the image to our container registry. It's a new image, therefore it has a new image digest, and therefore it needs a new attestation. We then pull in that new coverage attest container to run our test check against, and that step now fails. Right? A few key takeaways from this scenario. One, you get early feedback for your engineers, right? So you get that feedback much earlier in the software lifecycle that you're not meeting a certain control point. Two, it supports an evolutionary model, right? So your control points are not static in time and evolve over time. And three, segregation of duties. You can achieve segregation of duties without impeding flow, right? So you can bake into the CI/CD processes, for example, to provide that early feedback, and that really helps with flow, and we'll cover this in a lot more detail when we talk about the benefits. All right, so we're going to move to the third scenario where Bal, in all of his wisdom, has determined that we don't really need this test coverage check. We're just going to remove it, and let's see what happens then.
Thanks. So we all know how cumbersome governance can be at times, and to be honest, I think 94% test coverage is actually pretty good. So what we'll do in this demo is remove that coverage attester and hopefully speed up our pipeline and just get rid of that altogether. So here we have our cloud build pipeline defined as code, and we'll move down to the step where we have it mentioned and completely remove that. So we'll just quickly delete it, and then we'll push up that code to generate the new pipeline. Switching over to the terminal.
After testing our build pipeline locally, like Shori and Effie touched upon.
Yeah, so using all best practices. So
we did that behind the scenes.
Cool. So now that that's pushed, we can look over to Cloud Build and make sure our build's up and running. And just like last time, we'll check our cluster to see that our old workload is still up and running, that nothing's interfered with that. Cool, so it's still there. We'll move back to Cloud Build and we'll see hopefully the new representation of our pipeline. So as you might notice, the second last step, which was our coverage attester, is completely missing now, and it should result in a speedier deployment. Now what's happening behind the scenes is that we're polling Kubernetes to make sure that our deployment's gone through. And we have a specific wait time after which it'll come back with a response, whether positive or negative in this case. It was a lot quicker during the practice runs.
Because it's playing at 1.5x.
Yeah. Okay, so it looks like our deployment's been denied. Let's go over to the cluster to see exactly what's going on. So our workload's failed to deploy, and essentially what this error message says here is that we haven't been able to find a matching attestation for this deployment. Cool. So we'll move on over, I guess, to see what happened behind the scenes in this case. So we still have the same steps as we did earlier. We build and push our image through a Docker registry, and then we move straight ahead with our deployment. And once again, our friend, the enforcer, will intercept this deployment and make sure that it's following the policies that have been laid out by a control owner. So it checks for the policies, and as we know, a matching attestation is required, and it will look for that in the metadata store. As it won't be able to find one, our deployment will be blocked, and I guess we have to reintroduce that step. But essentially what this demonstrates is that although we have complete autonomy and control over our pipeline, we still can't easily circumvent this control. So I'll hand over to Satyam to talk about the benefits of this model and what else we can automate with in this governance team.
So we use the example of test coverage in these scenarios, but you can take a lot of different other controls and codify them. For example, build provenance. Was your container image built from source code that you trust? For example, did you build it from commits that were signed using your developer's PGP keys that you know and trust? So build provenance can be verified. You can check for open source vulnerabilities, right? So you've got some sort of a scanner, black dark, twistlock, whatever you're using to detect for known open source vulnerabilities. Does that scan meet your organizational threshold or your appetite for your CVSS score, for example? And a host of other checks that you can today codify, and these just represent your machine actors, right? So these are all automated checks. You can also use the same model to bring in human actors. For example, the QA was doing exploratory testing. Did they find that they were happy with the results? You issue them a private and public key pair, which they can use to sign an attestation, right? So you can extend this it's not just restricted to machine actors, but it can also be extended to human actors. That obviously means that you need to have a strong key management solution, but that's something we'll talk about later. Let's talk about some of the benefits and challenges associated with automated governance. Benefits first. It helps in faster value creation. Hopefully you've realize that this helps in improving that flow of value from our engineers to our the flow of value from our engineers to our customers, right? By baking in those control points into our early on in our life cycle, you get to know about problems early on, and therefore you can get working software into the hands of your customers faster. You make your governance a lot more deterministic. If you've dealt with change management, you'll probably realize that it sometimes depends on how good a day the person on the other end is having and whether they'll let you change through. And sometimes it becomes very relationship dependent. Like, you know a person, you're going to Skype them, you're going to call them, and they'll say, okay, let's approve the change. But that's really inefficient, right? Yes, you want human interaction, but you want to save that human interaction for value creation and not for toil. So this makes your governance process a lot more deterministic. A lot of reduced wastage, and this directly translates to dollar savings, the same shortening your feedback cycle, and therefore getting a lot more efficiency out of the investment into your project or your product. Lastly, you get assurance as well as you get autonomy. And this is fairly critical because on one hand, the functions within the organizations who are tasked with assurance and are responsible to the board or responsible to regulators have the confidence that their control points are being met. The rich data that is generated from running these control points can be dashboarded or event logged, and alerts issued when those control points aren't met. And this can provide a lot of rich insights to how your organization is approaching, how your organization is performing. But on the other hand, your development teams, your engineering teams still have that autonomy because their build pipeline is essentially their bread and butter. So if a central team takes control of a build pipeline, that can lead to a lot of anti-patterns which you don't want to face into, right? And you don't want to become a bottleneck for 50 engineering teams within your organization. So this is great, right? Why isn't everyone already doing this? Why are we talking about it here? There are challenges. The first and foremost is the maturity of the ecosystem. A lot of the tooling in this ecosystem is still maturing. A lot of the patterns are still emerging. A great organization to refer to is Capital One. They've done some amazing work on governance and the clean room model, for example. But there are other open source tools as well, such as InToto, Open Policy Agent, and they're still maturing, and organizations are still determining how do we best use these tools to meet compliance needs. Second is organizational culture and support. You do need strong executive support to be able to pull off something like this. It involves changing processes which they've worked, right? Whether they're inefficient, whether they're painful, they have been working, one can argue, and bringing your compliance, risk, governance functions to the table and introducing a culture of software excellence within those functions is something that you do need a bit of top-down support for. And lastly is the technical maturity of your organization. If you aren't doing automated unit tests, automated governance is not something you should be thinking about right now, right? Automated testing is probably going to give you a lot bigger bang for the buck than automated governance will at this stage. It also assumes mature functions around identity and secrets management, right? This relies on the ability to cryptographically verify attestations. But if you don't have a strong identity function and the ability to assign private-public key pairs to those identities, you're going to find that the system stops scaling after a certain point. So either if you have a custom identity solution or if you're leveraging a cloud-native identity solution, you do need to think about that. So in conclusion, I think where we are today is our ability to deploy working software far outstrips our ability to release working software. Manual governance practices impose an inherent ceiling on our organization's agility. And these erode the benefit of adopting advancements such as Kubernetes, Istio, cloud-native practices. You're going to find that those practices don't really provide the value that the brochures promise because your organization's ability to move fast is limited. We're in this great migration to the cloud, right? And that presents an opportunity because a paradigm shift like this is likely not to repeat itself for a few decades, right? It gives you that opportunity to have a look at your governance processes and change that for the better. And lastly, if there's one thing we'd like for you to take away from this is build the foundations, because those foundations really enable you to start thinking about automated governance. But if you have built those foundations, if you do automate all the things, then don't stop because you can take your organization's agility to the next level. And that's it. That's all we have. Thank you.